Now learning physics will be great fun with a physics teacher, a solution to all problems in physics.
The physics teacher.
Two parallel plate air-filled capacitors, each of capacitance C, are joined in series to a battery of EMF V. The space between the plates of one of the capacitors is then completely filled up with a uniform dielectric having dielectric constant K. The quantity of charge which flows through the battery is, so we have to choose out of the given options which is the correct one. So according to the question, let's draw the situation that we have two capacitors that are air capacitors and each has capacity C and they are connected in series, and this is the potential drop V across this arrangement. Now as both the capacitors are in series, so the charge on each capacitor is same. Clear? So let this is Q. So from here we can write that Q is equal to the capacitance of the system, that is C by 2, and the potential drop is V. Next, what he is saying, the space between the plates of one of the capacitors is then completely filled with the uniform dielectric having dielectric constant K. So he is saying to fill the space between the plates of a capacitor with some dielectric. So suppose we fill the space and the dielectric constant is K. Now again the capacitors are in series, the potential drop V is same. Let the charge on the plates of the capacitor is Q dash. So this is minus Q dash. They are in series, so this is again Q dash minus Q dash. Now the capacity of this capacitor is say C dash, that is K times the initial capacitance. The capacity of this capacitor is C, so the equivalent capacitance of the system, equivalent capacitance is C dash C divided by C dash plus C. So from here you can write KC into C divided by K plus 1 into C. So from here you can write that equivalent capacitance is K divided by K plus 1 into C. Now we have to find this Q dash, the final charge on the plates of the capacitor. So we can write Q dash, that is equal to C equivalent into V applied. So C equivalent is K divided by K plus 1 into C into V. Now we have to calculate the quantity of charge which flows through the battery. Initially the charge on the plates of the capacitor was Q, now it has become Q dash, so the charge that has flown is Q dash minus Q. So this much amount of charge has flown through the battery. So in order to calculate this, substitute the values K divided by K plus 1 into CV, and this is CV, so minus 1 by 2 into CV. And if you solve this equation, you will get K minus 1 divided by K plus 1 into CV by 2. Clear? So it is Q dash minus Q, the amount of charge that has flown. So the option A is the right option.